Welcome back to ArmanisMath. Today we're going to focus on finding the x and the y intercepts. Here's a warm-up. Give yourself about, for this one, probably say a couple minutes. I'll put the timer here for you. I'm not going to wait until the 2 minutes, but it's just for you to pause the video and try the warm-up. It's very important to start the warm-up. Okay, so in this warm-up we're asked to graph y equals x squared minus 4, and it does look like it's a quadratic, and it does look like it's a happy face, and I could tell that we are with the vertical shift of -4. You could tell this is the k term. So nothing else is happening here except the -4. So instead of starting at 0, 0, we are actually down here at -4. So how do I plot the points? Well, one of the things that you learn by now is to make yourself a table when you have a function. That's probably the easiest one to do. And we've learned through our Math Live to pick some points. You don't have to pick my points, but you've got to pick some points, and the points I'm going to pick is -2, -1, 0, 1, and 2. You could pick any points you'd like. Try to pick easy, friendly points for you when you plug them in. So I'm going to plug in -2. -2 squared is 4. 4 minus 4 is 0. I've got -1. -1 squared is 1. Minus 4, that's -3. 0 for x, that's -4 for y. If I plug in 1 for x, that's 1 squared, which is 1. Minus 4, that's -3. Interesting. I thought I saw this before. Yes, you did. How about 2? 2 gives you 4. 4 minus 4 is 0. I also saw this before. Yeah, it's over here. So interesting. So if I were to plot these points at -2, 0, I have a point. I got -1, which is here. This grid is like every tick here. I think it's about every 2 ticks is 1 here for this grid. So I've got -1 and 3, which should take me down here. And 0, -4 is here. I bet you the other one is here. 1, -3 is here. And lastly is 2, 0, which is this guy here. Now you gotta excuse me, I'm not, I don't have a graphing tool that is more precise, so I will do my best with this here, and you should end up with something like that. Almost to this here. Okay. Okay, a little bit overshot here, so it's about this. Basically, you're looking like a happy face. The key points that I wanted you to get from this warm-up is the intersection between the graph and the x-axis. We call these points the intercepts. And because you're touching the x-axis, we call them the x-intercepts. If you're touching the y-axis down here, we call that the y-intercepts. You might want to also label these if you're taking good notes. This is the y-intercept, y-intercept, and these both are the x-intercepts, x-intercept. We've got 2 of them here. X-intercept. Okay, so 1 point here, 1 point here for the x-axis. You've got 1 of touching point here for the y-axis, referred to as the y-intercept. All right. Where in the whole world are we using this? Well, there's real-life application for the x and y intercepts. And for example, if you're relating the mileage, the gallons, for example, towards the mileage that you could drive or traveled, you could use basically the x and y intercepts to model that. For example, like after how many miles are you going to hit, let's say 16 gallons of gas. Okay. Any other example that you could think of, you could Google that and share that with us when you watch this later, or maybe in the chat or the YouTube live or wherever you might be. Alright, the objective is I'll be able to find the x and y intercepts for linear, quadratic, and absolute value functions. So apparently we have more than one function today. So the first one is linear, and the second one is going to be quadratic, and the third one is going to be absolute value functions. So you're going to find the x and y intercepts of these three functions. I wanted you to try things, so I'm going to do the first example for you. The second, I wanted you actually to pause before you look at the answers and try that yourselves. Okay, so it says here, find the x and y intercepts of the given function, and I have y equals 10 plus 5x. My biggest surprise and gift for you today is for you to use something called a little t-table. Okay, draw yourself just a little t-table like this, and have x here and have y here. All right, and one time you substitute 0 for x, which will give you the y-intercept. So I'm going to say one more time. You substitute 0 for x, gives you the y-intercept, and you're going to substitute 0 for y, which is going to give you the x-intercept. So if I put 0 for x, that's going to give me where is my touching point on the y-axis. So let's try this. So I have 0 for x, which means this guy is 0, and y equals 10. So basically your graph in this example, it's a line because it's linear. You could tell it's linear because the highest exponent is 1 on the variables here, right? There's 1, here's a hidden 1. So that's why it's linear. When you graph linear, you're going to end up with a line. So I'm gonna graph this eventually, but I'm gonna hit the y-axis at 10. I was able to find the y-intercept by making x 0. Excuse me. Now what if I put 0 for y? Well, if you put 0 for y, that's gonna give you the x-intercept. So if this is 0, then you have yourself. Let's solve it here for you. Then you have yourself 0 equals 10 plus 5x. Subtract 10 from both sides. You got negative 10 equals 5x. Divide by 5 or multiply by 1/5. It's the same thing. So it's going to give you a negative 2 equals x. So basically this x is going to be negative 2. What does that mean? At negative 2, you will intercept this x-axis. All right? So let's graph this. Basically, I'm going to have a graph. It's going to look a little bit awkward because you're touching the y at touching the y at 10 and the x at negative 2. So I'm going to make it a little bit feasible for that reason. So I'm going to go here and say this is negative 1, negative 2, because that's this point here on the x-axis. You're touching that point. That's my touching point. That's my intercept. And I've got to count 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'm somewhere here. Okay, 0, 10 would be all the way up here. So that's my y-intercept. Okay, so I got the y-intercept by making x 0. I got the x-intercept by making y 0. And I'm gonna try to graph this as meticulous as possible. Okay, so that's where your line is touching. You might want also to put that in a point format, like a coordinate point, which is in this case 0, 10, and you say this is the y-intercept, obviously because you're touching y at that point. Y-intercept, and this is negative 2, 0, and you call this x-intercept. All right, so the whole point here is to get the x and y intercepts. I was able to do that by making myself a little t-table, and one time I substitute 0 for x, which is going to give me the y-intercept, and substitute 0 for y, which will give me the x-intercept. All right, let's try this one together, or you could pause again before you see my solution. I'll give you a few seconds here to think about this. All right, so we're asked to find the x and y-intercept for this given function. And once again, my biggest gift for you is to use something called the t-table. It's actually free. It's a very good table. I love the t-table. Okay, make yourself a t-table. Make yourself comfortable. I mean, grab a chair and stuff and look at that. Sit down and enjoy the scene here. Okay, why? Got 0 for x. And let's see what's going to happen. If I put 0 for x, which means I'm looking for the y-intercept. So if I put 0 for x, that's going to make this guy 0. That's going to be -6. So I am touching the y-axis at -6. I am intercepting the y-axis at -6. Right? And the second one is to make y equals 0. You make y equals 0 because you want to find the x-intercept. So if I put 0 for y, 0 for y, that's going to make this thing 0. So 0 equals to x minus 6. I add x6 to both sides. 6 equals to x. So divide by 2 or multiply by 1/2. X equals 3. So I am touching the x-axis at 3. So if I were to graph this dude here, I will have 0, -3. As I have to adjust my graph a little bit. I know it's going to look a little bit awkward, but the idea here is to get the point that we need. So I am here at 0, -6. So 1, 2, 3. That looks like a cross here. 4, 5, -6, -6. That's my y-intercept. Okay. And I have 3 zeros. 1, 2, 3. 3. That's my x-intercepts. And I'm just able to graph a line between them and call that linear because it is linear. By the way, what makes it linear? How do you know it's linear? Well, I know it's linear because the highest exponent I see on top of the variable is 1. Look at that. It's 1 here. Hidden 1. How do you know it's linear? Well, again, the exponent on top, the power on top of the variable is 1, not on top of the constant. This could be 6 squared, 6 cubed, that doesn't matter. The variable itself, the x and y. Okay. So I know it's going to be a line, and that's what I got. I also know something else. I know it's going to be a positive slope line. See that? Positive rate of change, positive slope. I know I'm going to be walking up, climbing up as I'm reading the graph from left to right. I'll be climbing up. I could tell. That's me climbing up. See that? Because of this 2 is positive. Okay. So anyways, again, you could put them in a point format. So this is going to be 3, 0. You're going to say this is x-intercept. And this is negative or 0, -6. And you call this the y-intercept. All right. T-table again is very powerful. And sometimes I make actually these zeros make look a little bit pleasing. So I'm like, hey, I found it. Woohoo! How about here? Oh yeah. Woohoo! Look at that. I found the 0. I found my intercept. Some functions have more than one intercept. We saw that at the beginning, right? At the quadratic. More than one x-intercept, right? So some functions have that as well. Let's take a look at some of them. All right. Now this one is the absolute value function. So I have y equals absolute value of x minus 2. Absolute value of x minus 2. I believe I remember the absolute value function, the parent, the papa function, looks like a V shape with the vertex at 0, 0. I remember that, yeah. So if I like the x and y axis here for the absolute value function, it looks like this. That's this here, this, and this is a vertex. I remember that. Okay, not sure about you, but I do remember that. So I'm expecting to see this transformation All right, transformation of the function. It could mean translation, that is a shift, or it could mean some other things like rotation, like reflection. Also could mean some other things under transformation. But let's just take it easy. We're only talking about translation here. So it's just like when you translate from, let's say, English to Japanese, or English to Spanish, English to Portuguese. You want to maintain basically the same thought process, and also as much as possible the words, right? Word for word, as much as possible, obviously. So that's what's going to happen here with this is called a vertical translation. Okay, so apparently I'm looking here and this guy's going down. This is a K term, by the way, and this apparently is going down. So the K term is it's easy because you follow the sign that you see here, up and down. Up is positive, down is negative. Unlike the horizontal shift, which follows the opposite sign. Anyways, that's for a different topic. But let's focus here. So I'm expecting this V shape. Nothing happens to the V shape here because just the absolute value. It didn't get bigger, didn't get wider or shrunk. There's no shrinking here. It's just a V shape, the parent, with one exception that it's a little bit shorter than the parent. So this guy is actually like 2, let's say, inches shorter than the parent. So if I were to graph this, which we will look at eventually, and I notice that it's not going to be here at 0, 0. It's going to be down here somewhere. So once again, if you want to find the x and y intercept, I will again suggest my surprising short tea table. Tea table. Sit at the table, get some tea. Okay. Drink some coffee. No, just tea. All right, tea. X and y. So if I put 0 for x, remember you put 0 for x, that's going to give you the y-intercept where you're touching the y-axis. Okay, if x is 0, that's going to be the absolute value. Let me solve it here. So if x is 0, y equals the absolute value of 0 minus 2. Well, the absolute value of 0 is 0. Basically, the absolute value concept, again, is the distance from 0. You're trying to measure distance from 0. How far are you from 0? That's the absolute value function. So if you're saying you're 0, well, you're not that far. You are 0. So basically here, y is going to be equal to -2. So I'm going to put -2. So I'm going to touch the y-axis. I'm going to intercept the y-axis at 2, -2. And what if I have the y equals 0? I want to see where this V shape is touching the x-axis. Okay. In this case, what you do is you put the y equals 0. So if I put the y equals 0, I'm going to erase here, put the y equals 0. That means 0 equals the absolute value of x minus 2. Now we got to really think a little bit here. So I'm going to add 2 to both sides. 2 equals the absolute value of x, or we have accustomed to start with a variable. So absolute value of x equals 2. Now think a little bit here. You're saying the absolute value, which is a distance, equals 2. So if you, for example, let me see here. If your house is between 2 subways, like subways, right? So there's a Subway here, sandwich, and here's a Subway sandwich store. And your house is exactly in the middle. You have a house, you must be lucky. You're right exactly in the middle. You're 2 miles away from this subway, and you are also 2 miles away from that subway. That must be an awesome location. Location, 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 real estate. So anyways, you're 2 miles away this side, or you're 2 miles away this side. So apparently you're measuring the distance. Distance, again, you're measuring the distance from 0. So if your house is 0, you're 2 miles away this way, you're 2 miles away this way. Well, if you're on the number line and this is 0, this will be a -2, right? And this will be +2. 2 away from 0 on the left is going to be -2. 2 away from 0 on the right is going to be +2. And that's why there is 2 intercepts here. So if you put 0 for y, as we did, this absolute value tells you there's 2 things happening. Either x equals -2, like you're 2 miles away left side of your house, let's say south side, and or 2 miles away on the north side, on the right side. Okay, so that's why you gotta have 2 in this case, 2 intercepts. X could be -2, or X could be 2, while Y is staying at 0. So that's 2 choices here for you. And by the way, to graph this, it's easier also to look at this as a point. This is the point here. You're not inventing points. You're not inventing anything. The point is here. That's why the powerful thing about that surprise t table, you'll get everything there. 0, -2, that's the point that you need to graph. -2, 0, that's another point. 2, 0, that's the last point that you need to graph. In this case, because you want to find the intercepts. So let me erase a little bit here and give myself room for graphing. So I know, as I told you, this is going to be a V shape because my knowledge of the absolute value function. The parent looks like a V shape. Ha ha ha. And let me see, what do I intercept? So I'm going to give myself just a little bit room. I'm going to be here, and I will be here as well. First one is 0, -2. So here's 0, -2. I'm down here. That's the y-intercept, and I've got 1 and 2, -2 here. That's a -2. That's the x-intercept, one of them, and 1 and 2. That's the x-intercept, the other x-intercept, which is 2. So I have myself a V-looking shape, which that's what I expected. It's not surprising, and that shape looks like this, as much as possible. See that? That's a V shape. And I'm down here because of the y-intercept at 0, -2. This is my y-intercept, and here I have two x-intercepts. Remember, I did this here. I did the x-intercept by substituting 0 for y, and I did that here. 0 equals absolute value -2. Well, then you have to really decide. The absolute value is the distance from 0. You're saying you're 2 miles away from 0, 2 units. Well, it could be this way or that way. That's why there's 2 choices. So this is 2, 0, x-intercept, number 1, or number 2 in this case. Doesn't matter which one. First one, usually left, right. So this is another x-intercept, which is -2, 0. These 2 points are your intercepts. Easy. Lemon squeezy. Okay, how about this one? Try this one on your own. I'll give you a few seconds. Please get started, and you should know at least that we're looking at the absolute value function. Okay, pause the video and do this on your own, and let's get started. Again, this is a V shape. I could tell, again, because of my knowledge of the absolute value function. I know the parent looks like this. This is the parent. This is not the child. This is the parent, and this is the child after its transformation. And one of the things under the transformation, which is that's a big word in the Bible also, transformation. You're transformed. So anyways, this one here, one of the transformations happening in this case, which is the only one, is called translation, which basically it's called, in this case, it's a vertical translation. You're basically affecting the y-axis. So this is the k term, and in this case negative. That means I'm going down 4 units. So instead of 0, 0 here as the parent, I have to head down here 3 and 4. That child has to be down here. The vertex has to be down here. Alright, so what we do? Well, remember, we suggested the tea table. Look, come on, let's have a tea party. Alright, so I'm gonna have a tea party. Party, and here's x, and here's y. 0 for x gives me the y-intercept. Well, let's check. If I put 0 for x, blip, that's going to give me, obviously, -4, because absolute value of 0 is 0, negative 4 is the value. What if I put 0 for y? Well, let's put 0 for y. So let's do it here. If I put 0 for y, it's going to be 0 equals the absolute value of x minus 4. Okay, add 4 to both sides. So it's the absolute value equals 4. Or again, you could put 4 obviously and just reverse it because you have an equal sign. Doesn't matter which one you start with. We just usually start with the variable. So again, this is absolute value is going to be equal to 4. Once again, you're 4 miles away from your place to the closest, let's say, what's another good store here that we could think of? Let's say that you have two of your favorite stores, 2 of your favorite restaurants right next to your house, and they're both 4 miles away from where you're at, exactly 4 miles. But one of them you drive south, one of them you drive north. So like if you're in between here, if you're here, that's your house. This is you and your house, happy, and you're really hungry. And okay, so we got the store here. Maybe, and your friends or your parents saying, "Hey, go drive and get us some food or something." Okay, so it's 4 miles this way and 4 miles this way. If your house is the 0 point, so you could drive this way, that's negative 4, or you could have this way, that's a positive 4, right? That location is, right? You drive, the distance is positive, but the location for that store would be the negative 4 location and the 4 location. So anyways, there's 2 possibilities what we're trying to say here. So you either have a negative 4 or 0. You also get a 4 if you do that. And to graph this, also going to be pretty easy, pretty straightforward. And that's going to be, here is my y-axis, here's my x-axis, and I'm going to put 1, 2, 3, and 4. Voila! I just got my vertex for the child. And 1 and 2 and 3 and 4 and 1 and 2 and 3 and 4 and 1 and 2 and 3 and 4 is 4 is negative 4. Okay, what's the deal? Give me the points. Can you suggest points? No, it's here. You don't have to suggest anything. You already worked hard for them. Look at this. That's one of them. 0, negative 4. Okay, thank you. 0, negative 4. I don't have to work. I already worked hard for this one. 0, negative 4. How about this dude here? This negative 4, 0. That's this guy here. Well, immediately you know this is x-intercept because you're touching the x-axis. And because of the point, by the way. Point itself says negative 4, 0. You are on the x-axis, negative x-axis, and you did not move up or down. You're just 0. Okay, and from there you just have to come back. Actually, I should say link these points. So here's a child, and I mean, apparently we're just exaggerating a little bit for the graph here, but again, the only thing that happened to this child was it being shorter than the parent, let's say by 4 inches or something. So you basically took the child and shifted it down. You took the parent and shifted it down 1, 2, 3, 4, and you just like that. That's what you're saying here. Okay, so that's translation, vertical translation. You also could refer to as vertical shift. All right. Now let's talk about this example here, and I believe you remember this one from the warm-up. So how do I find the x and y-intercept for this given function? Well, Armani, come on. By now, I should know. I'll just make myself a t-table. Yes, t-table. So let's make a t-table. That's the easiest. Just make myself a t-table. A t-table. Just like that. And you could put x, you could put y. By the way, f of x also is the function, right? We're using equations throughout the lesson, but you know that this is also a function, right? You just f of x is the same in this concept is the same as y. I know this is an equation, but also remember this, we're talking about a function here, f of x. Anyways, so back to square one. We just have to put 0 for x. Okay, I'm gonna put 0 for x. Oops, I got to negative 9. So if I put 0 for x, that's going to give me the y-intercept, and it happens at -9. So basically, if I'm looking at this again, the parent function is a happy parabola, happy, like this, where it's vertex at 0, 0. That's the parent, okay? Not the child. The child will have to have some shifting obviously happen here, which we talked about at least 4 times by now. This guy is called the K term, which is the vertical translation or vertical shift. And it does happen to be negative, so again, you're just going down. Could it be positive? Yeah, it could be positive. In this case, it's negative. So that's number 1. And let's see, what if I put 0 for y? Now it becomes the fun part, because if I put 0 for y, let's solve it here. 0 equals x squared minus 9. Add 9 to both sides. X squared, I should say, equals 9. You gotta remember that this is x squared, and it's plus or minus the square root of what you see here. So x equals plus or minus 3. 2 choices. So you're going to say -3 or 0 equals 3. By the way, it doesn't matter how you organize these points. For example, you put the -3, 0 at the top, and then 0, -9, and then 3, 0. It doesn't really matter. But you know that you have 3 points here. So basically, if you're looking at these points here again, freebie points for you to graph, this is my y-intercept. That's when I touch the y-axis. Apparently, if the parent is here, and I should make it clear that the parent is here, 0, 0. You take in the parent all the way down here to -9. And where do these legs here touching the x-axis? Well, they happen at -3 and at 3. So let me try to graph this thing here. I'm gonna be a little bit, because I'm going all the way to -9, so I'll give myself more room here on the y and the negative y axis. So I'm gonna say, okay, this guy's going 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8 and 9. Down here I'm 9. Woohoo! 0, -9, which happens to be my y-intercept. Okay, now how about 1 and 2 and 3? 3. 1 and 2 and -3, -3. So here's another points for, and you really have to excuse my tool here, because it probably gonna be smooth as possible as I want it. And this one's gonna go here. Yoo-hoo! By the way, it should look like a curve. If it's not a curve, that I mean did something wrong. Obviously, I don't have a kind of tool that is with a precision to give you the curve, but this is a curve. It's not a line. You do not graph a line, otherwise it's going to turn itself into an absolute value, which is not what we have here. We have a quadratic. Quadratic means the highest exponent is 2, and you could see the highest exponent on the variable is 2. You see that? That's why quadratic. And it's a parabola. Happy face looking up, because the A term is positive. There's an A term here that's positive, and it's going down -9, the vertex, because that's what it says. The K term, as we talked about, is -9. Okay. So again, this is 3, 0, -3, 0, and both of these are your x-intercepts. All right, I believe this is the last one, and I need you guys to gear up a little bit, because we're almost done here. Okay, so find the x and y intercepts for this function as well. What kind of function is this? Is it linear? No, it's not linear, Armani. Why is it not linear? Wow, it makes you so confident. Well, because of this 2 here. The power is 2. That's why we call them. They have a name. Parabola. You could also say this is quadratic equation. Okay, quadratic equation. Linear. This have to be 1 here at the top, not 2. Also, it could not be absolute value, because you need the protecting bars for the absolute value, if that's what you meant. But no, it's quadratic. Also, my thought on quadratic is always the parent. The parent looks like this. At 0, 0. That's the parent. Parent. Like they're more stable. They don't, like, they're very stable in their ways, and that's the parent. 0, 0. So how do I know the x and y intercept? Well, once again, you could use the short t table. T table. Not coffee. T. X. Y. Don't forget that this is also a function. So, function. We're talking about functions. So anyways, I've got 0 for x. Well, 0 for x, bleep. That's a big 0, which means at 5. So I'm touching the y-axis at 5. And let me see, what if I put 0 for y? Interesting. Let me put 0 for y. So 0, there's this. So think with me now, the y is 0. Is 5 minus x squared. Well, you could either add the x squared to both sides, so you can deal with positive x squared, and that's what I would do. Positive x squared, positive x squared. Basically, you're going to end up with x squared equals 5. And we just talked about that last example. Remember, this is 2 of them. This is x times x, so there's 2 x's. So that's why x by itself is plus or minus the square root of that amount, which I don't know the value for, but I know it's a square root of 5. Square root of 5 in my mind is between square root of 5 is between square root of 4 and what's after, what's a good number after the 4? Well, go big. What's after the 4 is the 9, right? Square root of 9. So square root of 9, if square root of 9 is going to give you 3, that's the value of it. Square root of 4 is going to give you 2, and you're a little bit closer to the 4. Do you see that? You're a little bit closer to the 4. So probably 2 point something here, which is closer to the 2. Not a big deal. I'm just saying you could estimate that. So 2 point something. I don't actually know the value. I don't have a calculator. I do not want to use a calculator. But I know it's below 3 and it's above 2, and leaning more towards the 2. So that's how I'm going to put it the way it is. I'm not going to bother with it. So it's going to be negative square root of 5. And also, if you put 0, you're going to put positive square root of 5. So 2 values for this guy here. All right, so let me graph this, and I could graph it perhaps by giving myself more room on that side. And 0, 5. So 0 is 1, 2, 3, 4, 5. Here is my y-intercept. Okay, 0, 5. How about the x-intercept? Well, you got one of them at square root of 5, which we said is a little bit closer to 2. So it's 1 and 2 and 3. You're somewhere here. Negative square root of 5. And 1 and 2 and 3, you're pretty closer to the 2. You're closer to the 2 than to the 3, so you're here somewhere, square root of 5. The question now, how does this look like, Armani? I thought this is a happy face looking up. Well, look closely. If it's a happy face, that means this guy is positive, but this guy is not positive. Which means I actually am looking down, meaning I'm a frown face, like this. Okay, and the vertex here, the tip, the maximum point is here, and if I were to graph it, I'm going to end up with, let's stick with this color here, I'm going to end up with something like this here. Remember, you have a tool, something like that. So I'm a parabola, I'm looking downward because of the A. There's another way you could write this if it makes your life easy. There's another way that you could rewrite the equation to make it easy with the function. You could say this is f of x or y. Let's stick with y here for simplicity's sake. Y equals negative x squared plus 5. Maybe your eyes can see it better this way. So now you know, oh my goodness, we're talking about negative a. That means the parabola is flipped, is reflected on the x-axis. Okay, that's what this tells you here, this negative here. Okay, so what are my x-intercepts? Well, they're here. The square root of 5, the negative square root of 5. What about my y-intercept? Well, it's here. 0, 5 is your y-intercept. Y-intercept. And this is your x-intercept. 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 Okay, hopefully this helped you. If it did, make sure that you share. I do encourage you to subscribe and like. If you benefited from this one, definitely spread the word and share it with somebody else. Okay, as we always do, there is a minute of before the minute of hope, there's a quiz. Quiz yourself. Really? Yeah? This one is for you to quiz yourself. I would time myself, by the way, for each one of these, maybe a couple minutes. So you got yourself about 6 total minutes here. And I would do them before I look at this with you. So if you're watching this, make sure you pause before you look at the answers. Make sure that you try it, okay? Here we go. Here's the x-intercepts and the y-intercepts for these functions. I'm just curious, when you graph this one, how would number 3 look like? It's going to be happy or frown face? Comment below. All right. Well, we always end up with 1 minute of hope with Armani. You might are going through some hardship right now, or heartaches, or things of that nature, and you think that people don't understand you. But I want to encourage you today. There is hope. There's always hope. You never give up. And think of it this way: on the other side of the issue that you're facing, you will be a better person. Okay? We always look up and trust in God, and He's gonna see us through. He never failed us. All right, you guys, take care of yourselves. I love you all. Bye-bye.